and we can go from here. So tell me just a little bit about where do you go to school? Where are you taking Calc BC?
Ralston Valley.
Okay. And you must be getting very near the end of new material.
Yeah, I'm pretty sure we have this is Unit 10 and 11 combined, and it's technically Unit 10.
Yeah. Do you have a textbook, Kate?
Yes.
Is it Calculus of a Single Variable by Larson, Hostetler, and Edwards?
No, it's Calculus, AP Addition, Briggs, Cochran, and Gillette.
Okay. Not familiar with it, but I think the curriculum is, there's no subject like calculus where it's going to be in the same order. I can almost predict exactly the order of your textbook, the table of contents. In other words, what you did previous to Taylor polynomials was infinite series, right?
Yeah.
Yeah, and then what you're going to do after Taylor polynomials is you get into parametric equations.
That sounds right.
Yeah.
I think.
Yeah. Absolutely the hardest part of Calc BC. It's chapter 9 and chapter 10.
Perfect. That's what
chapter 9 being infinite series. How are you doing so far? What is your current grade in Calc BC?
I have a 95.
Wonderful. Wow.
So I mean, I usually understand the material pretty well. I was gone for the first full week of Calc C, which would have been the geometric sequences and infinite series portion. But I just took that test and I thought it went really, really well. I felt confident on most of my answers. And then we started Taylor polynomials, and my teacher just went really, really quickly, like zoomed through all the slides, and I don't really understand like necessarily where it's coming from, and I feel like I need to understand where it's coming from to
I don't blame
do
so
it.
I think I can answer
that. Okay, because we wrote down like the general formula for it, and it's the f prime of a over k factorial.
Yeah. What the purpose is to take simple functions like e to the x and see if you can write it as a polynomial. And it turns out that you can. If I create it as an infinite series, turns out that this infinite series, dot, 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 equals e to the x exactly. Now, why do we want to do this? There are some integrals that have no antiderivative. That one right there.
Yeah.
In other words, there is no function whose derivative is equal to that, which makes it extremely hard to integrate. Right? In other words, if you can't find the antiderivative, how the heck do you integrate it? Well, if we can approximate, or not even approximate, if we can substitute a polynomial instead of e to the x, well, polynomials are series. In other words, it's this added to this added to this. So the integral of that would be the integral of that plus the integral of that plus the integral of that. So when you take a complicated function like e to the minus x squared and convert it to a Taylor polynomial, it becomes much easier to integrate. And that's the reason we do it. That's one of them.
Okay.
Okay. Now, let's talk about exactly what they're doing. There's e to the x. Okay. I know it goes through this point right here, 0, 1. if I want a linear approximation to that, that wouldn't be bad, right?
Yeah.
In other words, my linear approximation is equal to e to the x when x equals 0. They're both equal, so that's a good start.
Mm-hmm.
Now, you can see that my linear approximation gets further and further away from e to the x as I get further and further away from 0. The equation
Yeah.
on that is y equals 1 plus x on that linear approximation. And I get that from the first derivative of e to the x. In other words, the most important thing about that straight line that I've drawn is that its slope is the slope of the tangent line at x equals 0 for e to the x. And if you take the slope of e to the x, you get e to the x, you evaluate it at 0, and you get 1. So the y-intercept on my straight line is 1, and the slope is 1. So this is a reasonable approximation as long as we are very close to 0. If I go out here to x equal 2, well, now all of a sudden I'm a long ways away from that, right?
Yeah.
Not such a good approximation. Well, if I use the second derivative in approximating e to the x, I get something like this. Well, that curve is not a straight line, it's a curved line, and it looks something like this. Wow, just adding the second derivative made it nearly match e to the x almost exactly.
Mm-hmm.
And I got this by using the second derivative. Taking additional derivatives, you end up with a polynomial that is exactly the same as e to the x.
Okay.
And now you can go back and integrate that e to the minus x squared, because you know what e to the x is. So figuring out what e to the minus x squared is, the polynomial, is not that hard.
Mm-hmm.
Okay? Now, there are three particular functions, and that is e to the x, sine x, and cosine x, that can all be represented by a Taylor polynomial. Exactly.
Okay. We did e to the x on the first day,
Mm-hmm.
and so I just copied that down, but it makes a lot more sense when you described it. And then I did the sine x and cosine x in class, and that's the one with sine as like an alternating series essentially.
Yes, it is.
Because
But the thing is that alternating series is exactly equal to sine x. And that's an amazing thing if you think about it. Think about it. Here's the sine curve. Okay? If I start with the first approximation, it's that. In other words, those 2 points agree. Y equal x. Okay? If I include the first derivative, it starts looking like this. If I include the second derivative, it starts looking like this. The third derivative, fourth derivative, fifth derivative, and you end up with the polynomial being exactly equal to that over the entire domain of real numbers. So if I want to approximate the sine of 0.1, just plug in 0.1 for x into its Taylor polynomial. Let me find, I have a list of them. Hold on a second. I can never remember where this page is. But, yeah, here they are. In other words, sine x, let me erase all of this. Let's say you didn't have a calculator.
Okay.
That's just the first three terms of sine x.
Mm-hmm.
If I wanted to know what the sine of pi over 2. Well, pi over 2 is 3.14 divided by 2, so that's 1.5, what, 6 estimate? So
Sure.
if I want to know what the sine of 1.56 radians is, I can use this. I'll plug in 1.56 in for x. And guess what it'll come out to be? 1. Very close to 1. We know the sine of pi over 2 is 1.
Okay. Because I had a book problem to estimate sine of 3.
So take its Taylor polynomial, plug in 3 for x, and take however, in other words, this does go on to infinity. It's an infinite series. But the beauty is that very frequently the first 3 terms will be accurate to within like 8 decimal places. It has an amazing accuracy rate. So
Okay.
you don't need to go out that far. What's the next term? Minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial, so forth and so on. But you would be able to do it manually without a calculator using this.
Okay. Because
Calculations on, by hand, which is harder than or easier than finding the sine of a strange angle. If I
yeah.
ask you to find the sine of 33 degrees, you wouldn't know where to begin without a calculator, right?
Yeah.
I wouldn't either. But I would convert it to radians, and then I would know where to begin. I would begin right there.
Okay, and then
Go ahead.
why? So there's ones that are centered at 0, and then there's ones that are not centered at 0.
Correct.
So sine is obviously centered at 0, correct? But
It
you could
can't be
also make
centered
it that
anywhere.
it's not centered at 0.
It doesn't have to be centered at 0.
Because the way I solved it, I used x, x is pi, and then because pi is pretty close to 3.
Okay. You could have used 3 exactly. And then
What?
just substitute 3 for x. In other words, you're in radians. And
Yeah.
all of calculus depends on you being in radians. Calculus doesn't work on trig functions if they're in degrees.
Yeah.
So when you say what's the sine of 3, it means 3 radians. And that's what goes in for x, is whatever x is. So you wouldn't have to necessarily use pi as an estimate. You can use 3, exactly. The estimate comes from how many terms you want to use. Do you want to look at the first 3 terms of that Taylor polynomial, or do you want to look at the first 7 terms?
Okay, so basically made
The
it
more terms you look at, the more accurate you will be.
Okay. So I could have just centered it at 0 and gotten an estimate.
Well, yes, absolutely. Okay. There are some functions that don't center at 0 well, like natural log.
Yeah.
In other words, you cannot take the natural log of 0. So when you go to figure out the Taylor polynomial, if you center the natural log function at 0, this is undefined.
Mm-hmm.
So they center it at 1. And that is defined. That's equal to 0.
Okay.
That's one reason why you want to center it, different functions at different centers.
Yeah.
It makes sense to center the sine at 0. It doesn't make sense to center natural log at 0.
Okay.
Have you gotten into intervals of convergence yet?
Yeah, that was the day I missed, and we also did the Lagrange error bound.
Yeah. Well, there is nothing harder in this book than the Lagrange error bound. I can conceptually explain it to you.
Okay, I'd like that, yeah.
Okay. If the sine of x is equal to some polynomial function, which is an approximation, plus some remainder, which is everything else. In other words, if I'm going to approximate the sine of x by the first, say, 4 terms of the polynomial, that's that. And everything that I leave behind, which is everything else out to infinity, is that.
Yeah.
In other words, it doesn't really do any good to approximate something if you don't know the error of your approximation. And the error might be small, it might be large, but it's r of x is what the error is. Because we know, first of all, that the interval of convergence for sine is from negative infinity to positive infinity. In other words, no matter what number you give me for the sine, I can use the Taylor polynomial, whether you give me minus 17,000 or plus 1,000,000. The Taylor polynomial approximates it really, really accurately. And if I went all the way out to infinity, I'd get it exactly. But obviously, you don't go out to infinity. You choose a certain number of terms of the polynomial for your approximation. Well, that means your approximation is going to be off by this amount right here.
How do you know what the error is allowed to be?
Well,
a lot of the problems have 1/10,000th or 1/1000th as error, but some of them don't specify.
Well, I can give you the equation for the error. I'm not sure what it's going to mean.
Because I have
extremely difficult to understand.
Because I have 2 equations written down.
Yeah, I'm not going to be able to work with your stuff at the moment, just because I am on the very edge of understanding this myself. Well, here's the thing. I get a Calc BC student about every 2 years. That's it.
Well, yeah. Probably because we don't want to admit that we don't understand.
Well, most people taking Calc BC don't always need tutors, but and that's probably, I get probably 8 AB Calc students a year, but I only get 1 BC student every couple of years. So all of the stuff that you're covering in Calc BC, I haven't looked at for at least 2 years. And these concepts are hard. Unless I have time to refresh it, there's just no way I'm going to be up on it. I might be up on some of it. I actually do have another Calc BC student at the moment who, what have we been covering? His teacher did it weird. They did arithmetic series or infinite sums about a month ago, and then they're going backwards. lately they've been doing differential equations and
Oh, yeah, we already did that.
yeah. And in other words, their curriculum, he had a very strange one. And although they've got, he told me they have parametric equations coming up next, just like you. So that's the last thing you're probably going to cover before they stop giving you new material and start reviewing for your AP test.
Mm-hmm.
I assume you're planning on taking your AP test if you're getting
Oh, yeah,
a
of course.
in the 90s in your class. Certainly you do want to take it, because if you can pass it, that's a college credit. And you won't
Well,
have to take this
yeah.
course in college, which I'm sure would be nice.
Yeah, I already don't have to take it in college, but I need to pass the exam to get to. I'm conditionally accepted to a university in the Netherlands, and in order to like affirm that, I need to pass the either A, B, or BC Calc exam.
Well, the AB Calc exam is much easier to pass.
Definitely, I would agree.
Yeah, no question about it. You don't have any of this stuff on that. If you were studying for the AB exam, I could help you a lot better, probably. There's going to be about a third of the material on your BC exam that I'm just not up to snuff on yet. Now, here's what I told my other BC student. I'm perfectly willing to help you, but you've got to send me your problems at least 4 hours in advance.
All right.
And then I have a chance to go through and make sure I can figure out how to do them before I have to do them in real time. And
Okay.
I mean, you might say, well, why don't you just read up on that next section? Calculus is too broad. It's kind of like with my other BC student. I don't know what he's going to hit me with next. It could be volumes of solids of revolution, or which they did after infinite series, if you can believe that.
Oh, that's weird.
It is weird. Improper integrals, where one of the limits is infinity. That they did afterwards. So if I don't know what the next new subject coming up is, it's really hard for me to prepare for it. But if you can send me the problems on paper, or however you get them, if you get them off of an internet site, direct me to that site or something, then I can probably be of some use to you. I'm not sure how much, to be honest. I don't want to oversell my capabilities here.
Okay.
This was hard when I did it 2 years ago. Very, very difficult. I had to spend an unbelievable amount of time refreshing my calc skills, because, boy, it's been 40 years since I graduated from college. I have a math degree from Mines. So I've been through all of this, but after 40 years, you really forget it all. And you kind of have to relearn it all in order to tutor it. So
yeah.
It's a bit of a problem, me tutoring at a level that it's a little bit higher than I'm comfortable with. Anyway, there is the formula for the remainder, and that will give you your margin of error as to how close your approximation is to the real value.
Okay.
The
I don't know
problem is this thing is almost impossible to understand. And I mean that. Even after, it's one of the few things I've ever read in this calculus book that even after reading it, I can barely understand it, their explanation on it. And I couldn't even begin to explain it to you today. If you said, explain Lagrange's remainder to me tomorrow, I could at least show you an example of how to use it.
Okay.
Okay, I'm still not sure I could do problems that you give me, because that's a whole different story. In other words, it's one thing if I can find a problem in the book and go through it with you and make sure you understand every step that they're doing along the way. That has some value. It's not as much value as being able to do problems. Now, I can do problems like working out the Taylor polynomial for elementary functions. I know how to do that. But this Lagrange remainder is a seriously difficult.
Then I mean, this is probably unanswerable then, but on the functions, for example, natural log, where you would have to set a bound. I don't know if you know like how you would go about setting a bound for it,
Well,
because
now,
obviously
first of all, there's something else about natural log that's different than sine.
it's undefined and it can't have a negative.
Well, no, its interval of convergence is 0 to 2. In other words, if you're talking about numbers above 2, then the Taylor polynomial is not going to be a good approximation for natural log. There's only 3 functions that I know of that the radius of convergence is negative infinity to positive infinity, and that's sine, cosine, and e to the x. But if I look in my table of these power series for elementary functions, a lot of them have intervals of convergence that are very, very tight. Like if you wanted to estimate what 1 over x was. Well, there's a polynomial for doing that, but it's only going to work when x is between 0 and 2.
Okay, because I just watched a video on the radial convergence, so that has to do with
Yes, that's the same thing as interval.
error bounds.
Well, the error bound has more to do with that Lagrange thing.
But you can't approximate a function. You could not approximate a function in a bound where it diverges, because then your approximations are just going to keep getting further and further away.
In other words, here, let me give you an example. If I wanted to approximate this, it doesn't have to be one of those trig functions or exponential functions. This Taylor polynomial does a great job of approximating it. You can try it. Try plugging in anything you want for x and see if this doesn't work. It will. I'll bet you that will approximate it to within about 8 decimal places. In other words, if you plug in 2 for x, that's 1/3, right? This will come out to be 0.333333 if I plug in 2 for x. In other words, 1 minus 2 plus 4 minus 8 plus 16 minus 32.
Wait, okay, for that Taylor polynomial, why aren't you dividing it by factorials?
Well, because that's not the way it ended up coming out. They all come out a little different. I'm not sure what happened to the factorial on that one. I didn't work this out. I'm looking at a table.
Okay.
Power series for elementary functions.
Canceled out. Oh, they cancel out with the next term, because if you have.
They might. I'm not sure why there's no factorials. Most of them, the log ones, the e to the x, sine x, arctangent, arcsine, they all have factorials in the bottom. In other words, factorial is part of the process. I don't know why 1 over 1 plus x does not have the factorials in the denominator. It just didn't come out that way.
Yeah, I think they probably can.
If you use the definition of Taylor polynomial to figure out what it is, this is what you get. Dot, 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 dot. Okay? It also, the interval of convergence here is only minus 1 to 1. Notice what I did, the mistake I made. I tried substituting 2 for x.
Oh, so then.
It's only going to work if my x values are between minus 1 and 1. I was wondering what was going on because I was doing the math here and I don't get 0.3333.
Okay.
Okay.
Because it's not in the radius of convergence.
That radius of convergence is really important. That means that if you're going to use this polynomial to approximate that function, then x has to be in your radius of convergence.
Okay, and the radius of convergence is found with the ratio test. I think I understand that one.
Yes.
And then you have to find where it is inconclusive and see if the function converges or diverges in order to include it in the bound.
Exactly, you got it.
Okay, so then you have to make I could just find the radius of convergence in order to find the bounds.
Well, for the natural log, that question you were talking about?
Yeah, it was natural log of 1 plus x.
Well, the natural log of x has an interval of convergence from 0 to 2. So the natural log of 1 plus x probably has an interval of convergence from 0 or from 1 to 3 is my guess. But that's not going to be your margin of error. Your margin of error is, let's say that let's go back and look at this polynomial here, and I decide, okay, I'm going to let x equal 0.7. Okay?
Mm-hmm.
So what is 1 over 1 plus 0.7? Well, we could do that in a calculator, but this will also give it to me. But that is an infinite series. So I have to decide how many terms of that I'm going to use to approximate this thing. Let's say that I use just those 4 or 5 terms right there. Then my error is everything I didn't include. It's minus x to the 5th all the way out to x to the nth.
Okay.
That's the error. It's got to be, right? Because we know if we include the entire infinite series, it exactly equals that as long as we're inside the interval of convergence, which means that if I only use the first 5 terms, I'm not getting exactly equal to it. I'm getting exactly equal minus the rest of it that I didn't include. That's the Lagrange remainder.
Okay.
And that has a really tough formula, harder than Taylor polynomial formula.
Yeah.
Okay.
I think I actually get most of it.
Okay. Let's go ahead and end today's session. My first session here is always just a half hour. And like I said, I am perfectly willing to help you if you can send me the stuff in advance. And enough in advance that I have time to work on it. I really don't, I love calculus. I do. I love tutoring it more than anything else. If you gave me a choice, I'd choose to do nothing but tutor calculus only. Seriously, I would. I love it. And the problem is I don't get enough students to be able to maintain my expertise on it. So I don't mind spending 2 hours refreshing to handle a student that's only going to do an hour session or a half-hour session. That does not bother me because I know it's increasing my knowledge, and the next student that comes along, I'll be able to do it without that 2-hour preparation. So don't let that affect your decision. If I can be of help, that's the only thing you should care about. And if I can help you, I'm happy to. I'm not positive I can. You might be up near the limits of Calc BC where I can easily give you help. I know that the Unit 10 that you were talking about that follows infinite series, that is really, I've only had to do that one time with a student. And I was spending like 3 hours for every hour, and I'm still not expert on it. So it may be that if you're getting just into that area, I'm not going to be a lot of help. I apologize. I wish I could, but I just don't have the level of expertise that you're going to need.
I mean, I'm like relatively, I understand calc relatively well. It's pretty logical and formula based.
Mm-hmm.
And overall I'm doing pretty well in the classes. Just I missed a lot of school when we started this unit, and then I missed just a few more days, and then it's hard to learn it on your own.
It's almost impossible. For one thing, they go so fast in calculus, which amazes me, because who can keep up? Apparently you, if you're getting a 92. But you miss a couple of days of material, and boy, you better be able to read the book and catch up on your own, or you're going to be lost.
Yeah, exactly.
So, that's the truth, and it's primarily the speed that they go at. I don't know why they go so fast. It's such hard material. And to be honest with you, every calc student I've ever had, they tell me that there's 2 or 3 people in the class that understand it and everybody else is in the dark.
Yeah, that's probably my class as well.
A typical calc class, especially a calc BC class. Even though everybody that's in that class is smart, super smart. You don't get to be in that class if you're not super smart, especially in high school. When I went to high school, they didn't even offer calculus. I wouldn't have been able to take what you're taking right now until sophomore in college at Mines.
Oh, no.
And yet you're taking it as what, a senior at Ralston Valley? Yeah. That's a lot. I've felt for a while that they try to teach too high a level of calculus in high school. Some people can handle it. You obviously can. But most can't. I'm not sure I would have been able to as a 17-year-old senior. But
true. I think there's just a lot of pressure, especially at our school, and a lot of kids feel like pressure, like they have to take the class. So
well, there is, because it has such high, what do you want to call it, credentials. If you have passed Calc BC, and particularly if you've passed the AP test, that says enormous things about you.
Mm-hmm.
Far more than a high SAT score or a high ACT score. I'm sure you've been following this admissions scam.
Yeah.
My goodness. Parents were paying $100,000
just to get into
their SAT scores.
I know, it's crazy.
They should be paying $100,000 to a tutor to get their child through Calc BC, and nobody's going to care what their SAT scores are.
Yeah, exactly. Then
and that really is the truth. I mean, the difference between a perfect SAT score and understanding Calc BC is a huge gap.
Yeah.
I could get a perfect score on the SAT right now. But whether I could pass the AP Calc BC exam or not, I'm not sure.
Well, it's nice because apparently nobody at RV has ever gotten lower than a 3 on the BC Calc exam.
Yeah, I've heard that before. At Sheffield, there used to be a calculus teacher, and she ran an ad in our local community paper here, and she said nobody had failed to get, or nobody had ever gotten below a 4 or a 5.
Yeah, see, I don't know if I believe that.
I didn't believe it at all. Not 30 students. You're not going to, I don't care if you take the 30 smartest kids in the state. They're not all going to get 4s and 5s on that exam. They're just not. I don't know what her gig was. She probably wrote it off as a typo. She didn't mean what she said, or she misspoke or something. But, although they do grade it on a curve.
Yeah.
So, I mean, you might be able to get a 4 by just getting 70% of the problems right.
I mean, that's good.
Oh, yeah. No, if you can get that's what pass is a 4 or 5, right?
A 3 is passing.
Oh, a 3 passes also?
Mm-hmm.
Oh, I was under the impression you had to get a 4 or a 5.
Well, it depends. So passing the exam is a 3. However, there are specific schools, especially if you're looking at engineering or a math-based career. Colleges will only give you credit if you get a 4 or a 5.
Okay, that must have been it, because that's, yeah.
So yeah, it depends on the school for how much credit you get, if any, and depending on your score.
Yeah, I had a junior who was taking Calc BC, and she got an A in the course, and she didn't pass the AP exam.
Huh. That's interesting.
Strange, but I don't think it's probably that unusual.
Yep.
Because you can get A's a lot of different ways. You know, you can get A's by doing perfect on your homework and turning it in, or the teacher doesn't give you that hard of test questions, or whatever.
I mean, our class, we don't have to do the homework. It's all optional. The only grade that goes in are tests and quizzes.
Well, that's good. That's really the way it should be. They should
Yeah.
take all those students that got caught cheating on the SAT and just give them an SAT over. Seriously, to see whether they should stay at that school. If they can't take the SAT and score somewhere close to where they scored when they cheated, then they shouldn't go to that school.
Exactly.
So where are you trying? Are you trying to go to a school in the Netherlands?
Yeah, I applied to 3 schools there, and I was accepted into all 3, but I made my choice for University College Groningen. It's in the north of the Netherlands, and so I've been conditionally accepted, assuming I pass the AP Calc exam, and then I need to send them my diploma as well when I graduate.
And they said you can pass either the AB or the BC?
Correct.
Take the AB. Did you take Calc AB last year?
No.
You skipped straight from Algebra 2 Trig to Calc BC?
From pre-calc trig to calc BC, but so the way our school is set up is you learn pre-calc in like half the semester, and then you do trig, and then in January, February you do calc A.
Yes. Right, exactly.
So I didn't essentially skip
They
it.
think that works. I'm not a big believer in that, incidentally. I think a person should take Calc AB before they take Calc BC. Even if there is some overlap. You need overlap. When you're studying calculus, sometimes you need to read the chapter twice, you know?
Yeah.
But I could definitely, if you decide you want to take the Calc AB exam, I've got some practice tests on my computer. I could help you. I feel fairly proficient at that. I think I could pass that exam myself.
See, when you take the BC Calc exam, they give you both an AB and a BC score. So I physically don't have to take the AB Calc exam because I actually get a score for the AB.
They must have questions that are strictly Calc BC questions that they filter out and score you on just the Calc AB question. Oh, I didn't realize you did that. Well, that's nice.
Yeah, so
you might not pass the BC, but you might pass the AB, and that'll be enough to get you to your school. Okay. Yeah. Well, it would still be worth practicing on some Calc AB exams just to make sure you can do all of those.
Yeah. I mean, I'm pretty solid on Calc A. Most of Calc B, it's probably just the volume of revolutions of the solids that trip me up.
Well, I'm pretty good at that. All of those Calc AB stuff I can do. I get enough calculus students every year that I stay refreshed on that. It's just the Calc BC when they get into some of this really advanced stuff that I just don't come across it enough to stay up to speed on it.
Yeah, I mean, it's difficult. So.
It is. It's definitely difficult. I mean, have you taken AP Physics or anything like that?
Yeah, I took AP Physics last year.
What's harder, AP Physics or Calc BC?
In my opinion, I found AP Physics much harder.
Me too. Me too.
It just, honestly, it was because it was algebra-based physics, and now that I've taken calculus, I honestly think it would have been a lot easier had I known calculus back then.
Oh, it wasn't. Oh, I thought AP Physics was calculus-based physics.
No, so they had AP Physics 1 is algebra based, and it was really
Oh,
difficult to understand conceptually. And then once we started doing calculus, I was like, oh, this all makes sense.
okay.
The slope of the line is just the derivative. So if you have like
Right,
a
right.
velocity graph, the acceleration, it's so
Yeah,
easy to
once you
follow.
realize the relationship between position,
Exactly.
velocity, and acceleration,
And
physics
then you
makes
could
a
just take
lot
the
more sense.
antiderivative. Calculus makes physics a lot easier, in my
I
opinion.
can't even imagine how they teach in algebra-based physics, to be honest with you.
It's a lot of like deriving equations using algebra
Hmm.
and substituting variables, and honestly it just wasn't for me.
Yeah,
it
well, I
was
don't blame you.
it was harder than calc, although
Huh.
calc c
Huh. When I got
is.
to college, I found college physics at Mines, which is calculus-based, uh,
Yeah,
to be quite a bit harder than math. But I've always been a math guy. So for me, math is easier than physics. And
for me
I've actually
too.
tried reading a physics book lately to see if I could tutor physics, and no way. I'm not a physics person, but I am a math person. So I think it depends on the person. But
Yeah, no, I think I'm not as physics, it just like something about it is just really hard to understand,
yeah,
for me at least.
yeah,
And I mean, I would do like that was the first time I ever had to study for a class, so
yeah. No, that's my feelings too. That's why I started out as a physics major at Mines, and I switched to math because of that.
well, I don't blame you.
Yeah. I could handle the math. I'm not sure I could handle the physics, but anyway, that's where it's at. Kate, I wish you all the best of luck, and if I can be of help, I'm happy to
I'll
attend.
let you know. Okay, thank you so much.
Well, you have a good day and good luck in your pursuits.
All right, thank you. Have a nice day.
Bye bye.